Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from March 2023, paper 2, variant 2. In this lesson, as always we will discuss these questions in detail so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. Let's study together, let's improve together. In today's class, we are talking about March 2023, paper 2, variant 2, and total time for this exam is 1 hour and 15 minutes. And total mark for this paper is 60. On second page of exam paper, some important data is given to you. Means values of some important constants are given. If you need value of any constant in your exam, you can come to this page and you can find values of constants. On second page of exam paper, you can also find some important formulae, but these are not all the formulae you need for AS physics. So in the exam, if you have forgotten any formula or you just want to double check, you can come to second page and you can find some basic and important formula. For question number 1, part A, we need to underline all the SI base units in the following list. Ampere. Ampere is SI base unit of current, so we can underline this one. Coulomb. This is SI unit of charge, but this is not SI base unit, so simply we can leave this. Current. This is SI base quantity, but this is not SI base unit. Kelvin, this is SI base unit of temperature, so we can underline this one. Newton, this is SI unit of force because this is part of SI system, but this is not SI base unit, so simply we can also leave this one. So in this case, if you have underlined ampere and Kelvin, you will get 1 mark, and that is B mark. If you go to part B, for part B, it is given to us a car moves in a horizontal straight line. The displacement S of the car is given by this equation, where A is the acceleration of the car and V is its final velocity. We need to state 2 conditions that apply to the motion of the car in order for the above equation to be valid. Means when we can use this equation for the motion of the car. So for the car, we need to understand it is given to us the car is moving in a horizontal straight line. So the car is moving this way. Just imagine it is moving to the right. Then it is moving in a horizontal straight line. If you look at this equation carefully, we can simply figure out that this is coming from V square minus U square, that is equal to 2AS from kinematic equations, or simply we can say from SWOT equations. We have 5 equations, so this is one of them. Now in this case, if we compare these two, simply we can find out if U is equal to 0, then simply we can say V square will be equal to 2AS, and then we can make S the subject and we can write down this is equal to V square divided by 2A. So one condition for the motion of the car is that initial velocity of the car has to be 0. So we can simply say we can use this equation if initial velocity of the car is 0. So simply you can say if initial velocity of the car is 0, we can use this equation. And the second condition is that we can use this equation only if A is uniform, or simply you can say if A is constant, if A is uniform. So if A is uniform, we can use this equation. When we say acceleration is uniform, we are talking about magnitude of acceleration is constant. So we are talking about magnitude of acceleration that is constant. Then also we are talking about direction of acceleration that also has to be constant. Means the car has to move in one direction. So magnitude has to be constant and direction of acceleration also has to be constant. Means same direction all the time. So in this case, car is already moving in a straight horizontal line. So it means that direction is constant. So if we have to use this equation, then magnitude of acceleration also has to be constant. Because question is asking you, state 2 conditions apply to the motion of the car. I mean, what kind of motion car has when we can use this equation. So first one, initial velocity of the car has to be 0. And the second condition is that magnitude of acceleration of the car has to be constant. Magnitude of acceleration of car has to be constant. So simply you can say magnitude of acceleration is constant. Then we can use this equation for the motion of the car. I mean, this equation can describe the motion of the car. Magnitude of acceleration is constant. So you need to understand the whole physics, not just part of that. So if you adopt this kind of habit, always try to write down the complete answer, the right physics, the whole physics. You will develop your understanding of physics in a proper way. So magnitude of acceleration of this car, if it is constant and initial velocity is 0, then we can use this one. So we have to write down these 2 points. If you have written these 2 points, you will get 2 marks because this has maximum 2 marks. So one B mark for initial velocity 0 and a second B mark if you have written acceleration is constant, or if you have written the proper answer, magnitude of acceleration is constant, so you will get 2 marks. For part C, it is given to us an experiment is performed to determine the acceleration of the car in B. The following measurements are obtained. So value of S we have and value of V we have, and we need to find out value of A in this case. But in the last equation we have seen that S is equal to V squared divided by 2A, and now we need to find out value of A, so we can make A the subject. So A in this case will be equal to V squared divided by 2S, and value of V is given to us, that is equal to 2.75. 2.75 squared divided by 2 times, then value of S is given, that is 3.89. If we solve this one, our final answer will be equal to 0.972, and we have to write down this one up to 2SF, up to 3SF, because the given data has 3SF. So it's better to use 3SF. So our final answer will be 0.972. In the mark scheme, they have written 0.97, but the proper way of writing is up to least number of SF in the given data. So as given data has 3 SF, so we have to write on this one also up to 3 SF. So this is a good practice. But mark scheme is also accepting 0.97 up to 2 SF. Now if we go to the second part, for the second part, question is asking us to calculate the percentage uncertainty to 2 significant figures in A. Percentage uncertainty in A. So the percentage uncertainty in A, this one will be equal to percentage uncertainty in S plus percentage uncertainty in V. But in this V, V has a power. The power of V is 2. So we have to multiply this one by 2. And we have to ignore in this case this 2 because 2 is coefficient of S and it's not a scale factor. So it simply means that, for example, if I have X, this is equal to 2S, and we calculate the fractional uncertainty in X. So we will write down delta X by X, and this will be equal to 2 times delta S by 2S. So simply you will get this is delta S by S. So it simply means that 2 will be cancelled because 2 is a coefficient, but it is not a scale factor. So you can simply ignore this 2. Now we need to simply plug in values. We have percentage uncertainty in S, that is equal to 0.5%, 0.5%. Plus we have percentage uncertainty in V, that is equal to 0.8%. If we solve this one, our final answer in this case will be equal to 2.1%. We have to write down our final answer up to 2SF. So this is our final answer. So this is how you can write down final answer. For the first question, if you have got the right answer, you will get 1 mark, and this is answer mark. And for the second question, if you have written these steps, you will get 1 mark, and this is C mark. And if you have got the right answer, you will get another mark, that is answer mark. But if your answer is wrong, but you have written these steps, still you'll get 1. For the last part, we need to use our answers from C1 and C2 to determine the absolute uncertainty in the calculated value of A. Absolute uncertainty. In part C1 and C2, we have calculated value of A, and we have also calculated percentage uncertainty in A. Value of A we have calculated, that was equal to 0.972, and we have calculated the percentage uncertainty in A. And percentage percentage uncertainty in A was equal to 2.1%. So percentage uncertainty A, you can also write down, this is delta A by A multiplied by 100, and this is equal to 2.1. We need to calculate delta A in this case. So simply delta A, you can say delta A will be equal to 2.1 divided by 100 multiplied by A, and value of A we can write in 2.1 divided by 100 times value of A. A is equal to 0.972. Now, if we solve this one, our final answer will be equal to 0.02 up to 1 SF. So this has to be up to 1 SF because absolute uncertainty always at AS level, you have to write down up to 1 SF. So our final answer for this question is 0.02. If you have got this answer, you will get 1 mark, and that is answer mark for this question. So this is a proper way how you calculate absolute uncertainty. For our second question, it is given to us a motor uses a wire to raise a block as illustrated in figure 2.1. The base of the block takes a time of 0.49 seconds to move vertically upwards from level X to level Y at a constant speed of 0.64 meters per second. During this time, wire has a strain of 0.0012. The wire is made of metal of Young's modulus 2.2 times 10 to 11 pascals and has a uniform cross section. The block has a weight of 1.4 times 10 to 4 newtons. Assume that weight of the wire is negligible. For part A, we need to calculate the cross-sectional area A of the wire. Now, first thing we need to understand, for this question it is given to us, block is moving at a constant speed. As the block is moving at a constant speed, it simply means that the net force on this block is equal to 0. If we assume force F is acting vertically upwards, this is the force provided by the motor, then we can say the force acting downwards, this force is equal to weight, and weight and F, they have to be equal. So these two forces, they have to be equal in magnitude. So as these two forces are equal, we can also say in this case the tension in this wire, that is also equal to W. So we can also write down here tension is also equal to W, and W is equal to F. We need to calculate cross-sectional area, but in this case we have value of strain, we have value of force, we have Young's modulus. So simply we can use in this case that Young's modulus E, this is equal to stress over strain. So this is how you can relate this data, stress over strain. So simply first step you can write down E is equal to stress over strain, and stress is equal to force over cross-sectional area, and strain, value of strain directly is given to us, so simply we can use symbol for strain. For this question, we need to calculate A. So we can rewrite this one. So we can say Young's modulus in this case is equal to F divided by A times epsilon. And we need to calculate A. So we can make A the subject. So A in this case will be equal to F divided by Young's modulus times strain. Now simply we need to plug in values. In this case we have value of F, that is equal to weight, and that is 1.4 times 10 to 4 divided by Young's modulus. Well, if Young's modulus is given, that is 2.2 times 10 to 11, and value of strain is given, that is 0.0012. Now, if we simply solve this one, in this case our final answer up to 2SF, we have to use 2SF because given data, the least number of SF in given data are equal to 2SF. So our final answer is 5.3 times 10 to minus 5 meter square, because SI base unit of area is meter square, means SI unit of area is meter square. And so we can write down this is 5.3 times 10 to minus 5. And this question has 2 marks. The first mark you will get if you have written E is equal to this one. So we can say you have the C mark for this part. So if you have written this step, you will get 1 C mark. And if you have got the right answer, you will also get another mark, and that is answer mark. So this is how marks will be awarded. For the second part, we need to calculate the increase in the gravitational potential energy of the block for the movement of its base from X to Y. Means when the block moves from X to Y, from here to here, what is the increase in gravitational potential energy of the block? But for this case, it is given to us when the block moves from X to Y, the speed of the block is given to us. Speed of the block is 0.64 meters per second. And the time taken from X to Y is also given. That is equal to 0.49 seconds. And the block is moving at a constant speed. So in this case, we can calculate the distance between X and Y. So we can simply write down delta H xy is equal to the speed, means v times t. And so we can calculate first of all the change in height. So that will be equal to 0.64 times 0.49. So this is how we can calculate the change in height in this case. But we need to calculate the increase in gravitational potential energy, means delta GPE, the change in gravitational potential energy. And change in gravitational potential energy will be equal to mg times delta H. And mg is the weight of the block. And weight of the block we have here. So simply we can plug in these values. Weight of the block is equal to 1.4 times 10 to 4 times we have the change in height delta H, that is equal to 0.64 times 0.49. Now if we simply solve this one, our final answer in this case will be equal to 4,390.4. So this is up to 5 SF. But if you look at given data, this is given up to 2 SF. So simply we can write down our final answer. This is 4,400 up to 2 SF. So this is our final answer. And this is how you can figure out this type of questions. And this question has 3 marks. The first mark is if you have calculated the value of delta H, you will get 1 mark. This is C mark. And the second C mark is if you are using this formula, you will get another C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks. But if your answer is wrong, but you have written these steps, still you will get 2 marks. For part B, it is given to us the motor has an efficiency of 56%. And we need to calculate the input power to the motor as the base of the block moves from X to Y. Means when this block moves from X to Y, we need to calculate input power to the motor. So simply, first of all, we can imagine in this case, this one is the motor. So simply you can imagine this one is the motor. And motor has input power. So you can also draw this arrow. So this arrow is representing input power. So this is the input power. And also we can draw an arrow here. So this arrow is representing output power. So this is output power. And efficiency of this motor is given to us. Efficiency of this motor is equal to 56%. So this is efficiency of this motor. Now we can write down efficiency. Efficiency will be equal to P output, means the P out divided by P in, means the input power. And we need to calculate in this case P in. So P in simply is equal to P out divided by the efficiency of the motor. And P out in this case, simply we can calculate the force applied by the motor, means the tension in this wire. And this block is moving at a constant speed. We have already discussed this point. So the force acting downwards is equal to the weight of the block, and the force provided by the motor, means the tension in this wire, that will be equal to weight. And the value of weight is given, that is equal to 1.4 times 10 to 4. And the speed of this one is given to us. The block is moving upwards with a constant speed, that is equal to 0.64 meters per second. So simply we can say the power output is equal to F times V divided by the efficiency of the motor. And so force in this case is equal to 1.4 times 10 to 4. And this is the force provided by the motor. And that is equal to tension in the wire. And the speed we have, that is equal to 0.64. And we need to divide by efficiency. That is 0.56. Now if we solve this one, our final answer in this case will be equal to 1.6 times 10 to 4 watts. So this one is the input power, and here we have the output power. Output power is equal to this one. So this is how we need to figure out. If you have written these steps, you will get 3 marks. The first mark you will get if you have written this one. You have written P out is equal to FV, you will get 1 mark. So this is 1 C mark. And the second mark you will get if you have written this whole, if you have written this formula and you have plug in these values, you will get the second mark, and that is second C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks for this question. For part C, it is given to us the base of the block now has a uniform deceleration of magnitude 1.3 meters per second from level Y until the base of the block stops at level C. We need to calculate the tension in the wire as the base of the block moves from Y to C. So simply, first of all, we can draw a tiny block here. So this is the block at this point. Then the block finally stops at level C. Now we need to understand when the block is moving from Y to Z, in this case the force acting on the block upwards, that is equal to tension, and the force acting on the block downwards, that is equal to weight, and this block is decelerating. So it simply means that acceleration is in opposite direction of velocity. So simply we can say acceleration is downwards, and the value of acceleration is given, that is equal to 1.3 meters per second. And for this question we need to find a value of t. As block is decelerating and acceleration is downwards, it means the downward force is greater. So simply we can start from here. We can say in this case F net is equal to ma, and in this case, W is greater than T because block is decelerating, or simply you can say block is accelerating downwards. So we can say W minus T, this one will be equal to MA. So we need to calculate, in this case, tension in the wire. We need to calculate T. So simply we can say T in this case will be equal to W minus MA. W minus MA. So we move T to the right and we move this one to the left. So W minus MA, this is equal to T, and we need to calculate value of T. W we have, that is equal to 1.4 times 10 to 4. So this is the way, minus M. We need to calculate mass of the block. So mass of the block will be equal to weight 1.4 times 10 to 4 divided by 9.81 multiplied by acceleration. Acceleration we have, that is equal to 1.3. So if we solve this one, we will get our final answer, that will be equal to 1.2 times 10 to 4. And this answer is smaller than W. It means answer is right. 1.2 times 10 to 4 newtons. If you got answer bigger than weight, it means there is something wrong with your calculations. So this is value of T. So this is how you can calculate, and final answer has 2SF because given data also has 2SF. So we can use 2SF in our final answer. So you can simply write down 1.2 times 10 to 4 Newton. So this is the answer. And this question has 3 marks. You will get first mark if you have written this one. So you will get 1 C mark. And the second mark you will get if you have written this second step. You will get the second C mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks. For the last part on figure 2.2, we need to sketch a graph to show the variation with time t of the distance d of the base of the block from level x. Numerical values of d and t are not required. So in order to answer this question, we need to understand the motion of the block between x to y and y to z. We have already discussed that between x and y, block has constant speed. So simply we can write down block has constant speed, or you can say constant velocity, because block is just moving in straight line, meaning just moving upwards. And between y and z, block has constant deceleration, means the velocity is decreasing at constant rate, constant deceleration, and block finally stops at z. So we can say at z, speed of the block is equal to 0, means block just stops at z. Now we also need to understand that gradient of dt graph, this is equal to speed. Gradient dt graph, this is equal to speed. Now we have also discussed that block has two different kinds of motions. So simply we can divide this one into two parts. Between x and y, block has constant speed, and between y and z, block has constant deceleration. Between x and y, block has constant speed. It means the gradient of the graph has to be constant. It has to be a straight line. So simply we can draw the straight line between x and y. Because speed is constant, it means the gradient of line also has to be constant. So this is how you can draw between x and y. And between y and z, block has constant deceleration. It means that the speed of the block is decreasing. So gradient of the graph has to decrease. So simply you can draw like this with decreasing gradient. And finally at z, this has to be horizontal because block stops. So this part has to be about horizontal at z. So this is how you can draw the graph. If you sketch like this, you will get the marks for this graph. Simply we can draw in a proper way. Otherwise, we can redraw the second part. So if you draw like this, this is acceptable. So this is horizontal, it means its speed is 0. So horizontal is telling us gradient 0, it means speed 0. So if you draw this curve like this, you will get in this case 2 marks because this question has only 2 marks.